Okay, so let me start from the beginning. So, okay, in the last class we have seen uh, about how to use the MR unit framework to debug our MapReduce jobs, right? So today we'll see debugging our MapReduce job by putting some breakpoints in Eclipse, and also we will see the local runner concept. That uh, if what is the local runner concept? Basically, the difference between running the job. Basically, the difference between running the job and running the job on the distributed mode and on the local mode. What is the difference? That's what we will see then. So, what I'm trying to showcase right now is I would like to put a breakpoint. Okay, so let's say I would like to debug. I would like to put my breakpoint in my code, and I would like to go through the code. That how is my map method is working, or how my reduce code, or what all. If I give this input, how my flow is going on. I would like to say that. So I'll put a breakpoint. So I'll right click on it, and I say toggle breakpoint. You can click on that. Okay, so it will put a breakpoint. This blue dot. Similarly, I'm also putting a breakpoint on my in my word count mapper. So let's say I put it over here, because actually you are testing the map method itself in the using the embedded framework. So I've kept it here. So I'll go back to my testing class, and now what I'm gonna do here is I would like to run this, and I have put my breakpoint. So now I right click and then debug as unit test. So it will hit your breakpoint. So your execution will halt over here. It will not go further until unless you have a couple of keys you have pressed, like F5, F6, and F8. F5 is step into. For example, you have a method and you would like to understand that what's happening in the method before it returns. So you would like to go inside the method. So you press F5 to go into the method. F6 is like step over, means you have a method, you don't want to know what's going in the method, you just want to go to the next line, you press F6. Now F8 is like, you once you press F8, then it will hit the next breakpoint in the execution. Okay, now I'm pressing F6 here, I'm stepping over, and it goes to the next line. Okay, new. So if you remember, so I am actually, what I'm trying to test, this is my input with input hello, how are you, and this is my output which I'm expecting, and then what I'm saying, run test. So once it runs test, it's running your map method. So see that your key, whatever key you have outputted from, whatever key you have given from the testing class, and the value was hello, how are you, this was what you have given. Now it has came up, and you just wanted to see what's happening, so I'm pressing F6. Input value is this, then you're splitting onto words using this regular expression. So you want to see what is the array. So if you see that the array receives you hello, how are you, and what was the value, I mean the input hello, how are you, in a lot of spaces, and you wanted a regular expression that only splits onto words, and that's what you got it. That means this regular expression is fine. And then your logic says that you want to iterate, and then the first word comes as hello, then word dot length greater than 1, yes, that in the length of the word is greater than 1, the output is word and the 1. The next iteration, it will get a new word from the array how, and then in the next iteration it gets a new word r. You hover your mouse and you can see the value. So this is how you will debug. Yeah, that's one way. That's one way of debugging your MapReduce job, right? Correct. Now, for example, you want to run a subs. You want now. This is here. What you have done. You have given one line, but that is working fine. But you don't know the data set. You have a data set. Let's say Shakespeare data, and one of the line is throwing some exception, and you would like to catch that exception. That is your intent. So unit test cases, in these kinds of unit test cases, are like, you will give one input, sample input, and then you will see that what is the output, and then you will verify that. right? So here what you did, for example, in the last class I have told you that here is your input, hello, how are you? And then you are expecting, this is your expected output, that I wanted hello one, how one, r1. And then you give this, that I am expecting this output, and then you run that test. So it takes this input and get the actual output and match with the this expected output. Fine, this is fine for sample input. But let's say in a Shakespeare data, in memory, it will write into memory. So Vipin is asking a question that when it encounters context.write, where does it write to? So it will write into memory. Yeah. So here context.write, it will write into memory. Now, so I was explaining you that now you have a Shakespeare data, and somewhere some line is giving you some exception, and you don't know it. So in order to debug that, what would you like to do is you would like to run the MapReduce job on the entire data set, right? Now I have just told you entire data set. Okay, Shakespeare is a very small data set, it's okay. But there's a concept of, but okay, so what you do right till now, you put your data, you have put your data on HDFS, which gets broken into blocks, replicated, distributed across machine. Then you run your MapReduce job on on that data. So you have a couple of map task runs. So you have a, let's say I'm just assuming you have a 5 map task and 1 reduce task, and each of them runs on separate JVM, right? That means the 5 map tasks, 1 reduce task runs on a separate JVM. You can say that in other words, they runs a separate process altogether. So you cannot debug via Eclipse. If you would like to debug via Eclipse, then not okay. You can via Eclipse you can do you can attach your debugger to only one of the tasks. You can do remote debugging where you can attach to one of the tasks and do the debug. But you don't know which task is problematic and all, so it's impossible. There is no concept distributed debugging. In order to debug via Eclipse, entire MapReduce job should run on a single JVM. That's the whole point which I'm trying to tell you. In order to debug your MapReduce job using in Eclipse, you need to run entire MapReduce job in single JVM. And just now I have told you each of them, that is each and every map task runs on a separate JVM. Please note this, right? But here I'm saying you need to write the entire MapReduce job on a single JVM, and the concept of right, and the concept of running the entire MapReduce job in a single JVM is known as local runner. Local runner is nothing but is the concept. It's a concept of running the entire MapReduce job in single JVM. And how it is achieved? So it's just, so first before that, let me just go back here. Let me just take you to the whatever we have done. MapReduce job. Whenever you run the MapReduce job on cluster, your data is on HDFS. And right, your data is in HDFS, and you run locally, and you run in a distributed fashion, and you run your tasks, and tasks runs in distributed fashion. Correct. Fine. Perfect. But in local runner, the data will be on the local file system, on your local file system. which means that you don't require your cluster. You don't require cluster. In other words, you don't require any of the processes to be up and running. You don't require any of the Hadoop processes to be up and running. I'll show you that right away. Okay, that's a local. The data will be on the input data will be on the local file system. And out, of course, if everything is on the local file, so there is no cluster, there is no Hadoop processes needs to be up and running. So the output will also be created on the local file system. The output will also be created on the local file system. That's the important concept. Okay, and remember that if a task, if in a MapReduce job, let's say if in a MapReduce job, a 5 map task and 1 reduce task is running, it has to run, then all the tasks runs in sequentially. All the tasks, they run on a single JVM, runs on single JVM, and runs sequentially. Okay, so there is no distribution. There is no distributed fashion. So local runner is just for debugging purpose, not for your performance or anything else. Okay, so all the tasks runs on a single JVM and it runs sequentially. Fine. Okay, so let us go back to slides before we see that how to run our mapped job locally. So in local runner, as I've just explained you, that it uses a local file system, which means that entire thing will be using the local file system, no HDFS, nothing. Map and reduce task runs on a single JVM. So all the tasks will run on a single JVM and they will be running sequentially. And you can have only one reducer. So another important thing that in a map it is, and when you're running a job locally, you can have in local runner the maximum number of reducers you can set. The maximum number of reducers it will run is one. Will run is one, which means that even if you set in your even in the driver code, if you set job.set num reduce tasks equal to 100, let's say in your driver code, if you have even if you have set it as a 100 task, and if you're running the job locally, it will still run one reduced task. Maximum is one reduced task, irrespective of how many reducers you are getting. Maximum is one, and minimum is zero. So uh, so it does not matter how many reduced tasks you have set. If it is one or zero, it is fine. But if you have set, like say, more than one, it will still run one reduced task. That is one thing which you have to understand. And no distributed cache facility is available, so you cannot test the distributed cache. What is distributed cache? I'll explain afterwards. But there is no distributed cache. You cannot debug it. You cannot test it. And how to actually test this local runner is by changing the address of the name node and the address of your job tracker. In this case, a job tracker, but we have to change the address of the resource manager. Okay, so by changing the address, by changing how to run. The question is how to run MapReduce job locally or in a local runner. If anyone asks you, so you have to first you need to change the address of name node and resource manager. So what is that we have to change? The fs.default fs, it has to change to local, and the let me let me open the XML file, and then address of resource manager to local. I'm very sorry, not this one. Yarn.resource manager.address. If you remember, Not this property which we changed it. We in the resource manager.xml file we used to keep one more property which says it should be done in classic mode or a yarn or a local. I don't remember the property name, but we can go back and check out. Okay, I think I have to Google. Let me. I can pick up yarn-default.xml. Just 1 minute. I will just check out the property which I don't remember as if. Now MapReduce.framework.name. That's a property. The runtime framework for executing the MapReduce job can be one of the local, classic, or yeah. So I wanted to run as local. So I'll change the MapReduce.framework.name to local. Okay, so that's one. And I think I can also make the address of the name node. This is one property, MapReduce.framework.name. But framework.name equal to local. That means you want to run your MapReduce job in local mode. And also we'll change the address of our resource manager also to local. But it will not have any impact, I believe. So, but this is important that you are going to change the address of your name node as a local, right? fs.default.fs. Now, what my intention is to debug my MapReduce job, right? Debug my MapReduce job. What count mapper on a Shakespeare data on the entire Shakespeare data I want to debug. Okay, where is my XML file? This is my XML file for running my MapReduce job for what count. And QA, okay, default FS. As I've just told you, I'm gonna change it to local. I will also change this guy to local, and I have told you that we are going to add this property wherein it specifies that way we want to run our MapReduce job name MapReduce.framework dot name, and the value which you want to use is local. Okay, job name, this is fine, everything is fine. What I am going to again specify is the input and the output data. So input data, so by default by default when you run the MapReduce job on the distributed on your cluster, it will look out in the HDFS, but now I have to give the path of my local file system, right? So when you want to run the MapReduce job, when you want to run MapReduce job locally, specify the input path on which is on your local file system, not on HDFS. Okay, and similarly, the output will be created on a local file system when you're running a job locally. So when running the job locally, the output will be created on your local file system, not on HDFS. Fine. So let us see that. Let us provide the data for our um, Shakespeare data. Okay, so Shakespeare data is this. User K Sharma documents. This is my Shakespeare input data, so I'm gonna give it. This is my Shakespeare data. Output also I would like to give to user document Shakespeare word count underscore output. That's my directory. That's my output directory, which will be created as a part of my MapReduce job. Number of reducers are again at 0. Let me give it as a 1. To give you more clarification, I will run it as a 5, but in local learner you will not, even if you specify more than 1, means respect, it will not matter, it will still one and one reducer. So in local runner, if you specify more than one reducer, it will run not more than one reducer. Okay, now let us debug, or let us first run the MapReduce job from the Eclipse. So till now you have been running your MapReduce job by moving your jar to the cluster and then running it. Now at this time I'm going to run it from my Eclipse. So how you used to run it from the Eclipse? How you used to run it from your from by a command line? You always used to say Hadoop. This is a command you use to submit your job. Hadoop jar, your jar name, then you give your fully qualified driver class name, and then you say minus conf and your XML file. That's how you give it, right? Minus conf, and then you provide the XML file, and then run it. So when you're running from the Eclipse, you don't have to give this. Okay, so let me just show you. There is only one driver code. I believe everyone saw that there we are using only one driver code. Every time only one driver code. This is our driver code. So I'll right click on here. I'll go to run as. Right click on your driver code, run as, and go to run configurations. Okay, and this is your what count project test. No, not this method. I wanted to say. You can see on the left hand side, right? A lot of classes, but the browse project. And the project is the what count. I want to go Java application. Why it is going to my test classes? Right click, run as Java application, run configurations. Okay, it came up. You can see that, right? Word count driver, it has came up, but it was not coming till now. So I have clicked on Java applications, word count driver. This is my project. This is my main class, and you need to select the argument section, because everything after the jar, it's an argument for you. After this, after everything, it's an argument. So minus conf XML file. So what you need to do, you need to say minus conf and XML file, and you need to give the fully qualified apply close. You need to give the fully qualified name of your XML file. So what count, I say right click, properties, cancel. Select your class, run as Java. Very sorry. Great. Run as, run configurations, and give your XML file, apply, and then now you can run it. Now, if you open the console, you will see that it will start the mapper job locally, and then it will give you the output. Let us see. Some problem, I believe, because it has not ran. This way is not the only output it will give it to you. Run configurations, minus conf, okay, it has already created the output directory, I believe, word count output. Okay, that's why it is saying that it has. Okay, let me just see. Okay, so this has changed the implementations, I believe, now. So if you see that here, you can see all the 5 output files. So it's a newer version of your Hadoop. So I believe that's why the change, but it will not run more than one reduced tasks. So local runner. So maybe in the 2.7 they have changed. Fine. I'm not. So you can see that, right? Aron, abate, and everything is the same output. Yeah. So I'll take my word back that local runner I've just seen, because it's 2.7 version of Hadoop. So I've been seeing only one reducer it runs, but now you can see that most of the reducers are running. But the interesting thing, but what you have to understand from here, that it is the input data is local, the output data is also local file system. Okay, but let us see here. I would like to test one more thing, that I'll change my output directory first quickly, and I'll put my debug. I'll put my output directory. I'll take it as a 1, and now I will debug my map this job. So I'll put my what do you say? Uh, can use the breakpoint is here in my mapper, and also put my breakpoint in my reducer class. And now what I'm gonna do, I'll click on my word count driver, run as, sorry, debug as. I want to debug, so I will say debug as, and debug configurations. First, let me check whether debug configuration is already. It's anyways set it. Okay, and I'll say debug, and it will first hit my mapper code, and then it will start hitting my reducer. So now let us see what is the value. Value is empty here. Again, if I'm pressing F8, guys, if you can see that on your Eclipse, on your top, it's a F8 button by default. So F8 will hit the next breakpoint in the execution. So I'm resume, right? This is what you're seeing. I'm hovering my mouse on the top here. Now, if you press here, it will again hit your mapper code. And this time the value is again empty. Again, I'm going to press F8, and this time value is again here. And now the value has came as all's well that ends well, with some input data, whatever input data. Now I'll press F6. Now see the input value is all apostrophe s, and when you break it, it has all and s. You can see that all s apostrophe. So all apostrophe s has been removed and it has made two words. Now you see that okay, it is working fine and all. Now I have removed the breakpoint. So now I'll again run, and it will go and hit my reducer code. You can see that it has hit my reducer code, and the key, it is 12th, and then you will find out the values. You will iterate over that, and I'll again put a breakpoint, press the F8. What is the summation? 12 has appeared one time. Again I'll put it. This time key is 1s, the summation is 1. Key is 6d, the summation is 2. So I think it is working fine. So what I will do, I'll remove all my breakpoints and I will run it. Whatever the output I have given, whatever the directory, so word count op1. So I'll go back and check it out. So you have all the 5, or whatever the number of reducers, whatever it is. So that's how you can debug on the entire MapReduce job, and this is how you can run your job locally. So it is useful for debugging purpose. So either you should have, first and not either, you should have your Jane test cases, and local runner is useful. Local runner, of course, you should understand that you have a terabyte of data. You for sure you will not run your job locally. Locally, if you want to run your job, it is just on the sample amount of data. Don't run on the entire big data, right? It will first and foremost, you will not be able to handle that big amount of data on your local box. So local runner is useful when you have a local runner. What you can do, you can take a sample of data and you will run locally to see that actually it works. And MR framework, of course, it is required to test your entire flow, small test cases. So that's actually about the local runner. Okay. Now, so what we will do, we will stop it here today, and tomorrow we will start with our distributed cache, passing the parameters, and map side join. And I would say that in the next week we might be able to complete the entire development portion. Only few topics are left, like custom keys, custom values, custom partitioner, reduce side join, secondary sorting. Okay, thanks. Let's meet tomorrow.